we're going to the last and the third speaker and the last speaker of this segment, Smart Manufacturing, Mr. Jonas Berge, and he's the Senior Director of Emerson Automation Solutions. So without much ado, I will hand it over to Jonas. Over to you.
Green plant, a sustainable plant with no undetected leaks, no unaccounted emissions, no undetected passing, no hidden fouling causing inefficiency, and no undetected overconsumption. That is really the vision of sustainability and digital transformation in plants. Okay? Today I'll speak about three things. First, why plants are changing, because they want to become greener and more sustainable. Then I'm going to talk about how plants are changing through new work processes driven by automatically detecting inefficiency, losses, leaks, and overconsumption. And lastly, I'm going to talk about what plants are changing. They are adding automation, really towards hyper-automation, including sensors and artificial intelligence analytics. Okay, so I'm really going to talk about the why, the how, and the what. Okay, but I'm going to start with why plants are changing. Well, they want to become more green, they meet their ESG and CSR commitments, which include sustainability. Okay, yet plant equipment foul, it fail, it has suboptimal or incorrect settings, and so on. And this causes inefficiency, overconsumption, losses, flaring, and other CO2 emissions. Okay? So this is why plants want to change. So how do plants change? Well, Industry 4.0 or Fourth Industrial Revolution, digital transformation, digitalization, or Industrial Internet of Things, or IIoT, whatever you prefer to call it. Okay, that includes work practices that helps multiple domains. For improved reliability, greater sustainability, it makes the plant a safer place to work, and reduces off-spec product. Okay, but today the focus is on the sustainability part of it. Okay, and that's really enabled by automatic detection of inefficiency, losses, leaks, and overconsumption, and so on. Okay, and that enables plants to quickly fix it and restore plant performance, to reduce their energy consumption and thereby being sustainable. So what do plants need to do to achieve this? Well, they need to add in more automation. So until now, plants really been driven very much based on reports, with KPIs. Reports and KPIs tend to be lagging, end of the day, end of the week, that sort of thing. But become more proactive and respond, and therefore they need to have real-time dashboards with real-time indexes that tells them what's going on in the plant. Okay, and they get that on real-time dashboards. Okay, and which are personalized. Okay, so for instance, if you are involved in sustainability, then you would have oxygen or whatever utilities that you are using in your process. Okay, and all of this information in the dashboard, it comes from underlying analytics, so it could be from energy management information systems, performance monitoring analytics, condition monitoring analytics, and emissions monitoring analytics, for instance. Manual energy management is very time consuming, and it's also lagging, as in, manually reading, flow meters, etc. Okay, and metering at plant battery limits or at the source, like as these utilities cross into the plant or coming out of the boiler or compressor. Okay, that is insufficient. Okay, you need in-depth data and analysis of how energy flows throughout the plant. Okay, because this enables cost accounting, which drives consumption accountability. It allows you to detect and pinpoint overconsumption, to restore plant performance. It gives you automatic reports and dashboards, that automatically, right? So now you become more productive, but also more responsive and proactive. And it allows, mass balance and energy balance, so you can pinpoint leaks, and which drives repair. So that's really how plants have now become more sustainable. Yeah. So they are tracking these utilities from it comes in across the board to the plant or out of the production, and as it goes into the various plant areas and units and so on. And this is done through an energy management information system, or EMIS. An EMIS system, it has a software portion and a hardware portion. And everything is really built on top of the hardware platform, which is mostly like flow meters and electricity meters, right? What the software portion does, this is what you see right here, okay, it provides that granular consumption tracking, okay? So you see what is the consumption, not only for the plant as a whole, but in individual units or areas and individual units, and even down to individual pieces of equipment. Maybe not all, but at least all of the major consumers. Okay, so now you can see where energy is going. Okay, and there is energy account centers accordingly, and so this drives more responsible use of energy in the plant. Yeah. And the EMIS also provides, detailed consumption reports. So you don't have to manually gather all of the data. It's generated automatically, and also automatically generated performance dashboards. So you can see up to the minute what's happening in the plant. Perhaps most interesting, okay, is that the EMIS also provide, dynamically computes energy targets based on the production rate. Okay, so and that's done using an internal model. Okay, so let's say you're a refinery, and right now you're running at 250,000 barrels per day. Let's say that's your production rate. Well, based on that, the model then calculates what should be the consumption of water, air, gas, electricity, and steam, and other utilities. Okay, and and then it compares that against the actual measured consumption. Okay, so if you have overconsumption now, then that triggers that alarm, and it kind of pinpoints, where in the plant this is happening and which utility it is happening to. Okay, so now you can dispatch basically a troubleshooting team to fix that. Why is it over-consuming that particular utility at that particular place, and do something about it. The software then also provides that root cause analysis, okay? So it tells you, is it fouling of heat transfer surfaces, or is it inefficient combustion? Is something broken, or is there something running that really should have been turned off? And lastly, also granular energy and mass balancing, okay? So if there's a leak somewhere in the system, maybe in a piping system underground, you can kind of more closely pinpoint where this is occurring. Now, so this model used in the EMIS to compute the target, well, that's a good example of artificial intelligence, okay? So in the case of well-known unit processes, it's using models, which are based on first principles, because many unit processes are already well understood, and the first principles behind them are well documented. So that just goes straight into the AI model, okay? But there might also be not so well-known processes in the plant, right? And in that case, then you can use machine learning to extract knowledge from process data. So, and you can do that using, regression analysis or principal component analysis, okay? So now you extract that knowledge, those correlations, and you build a model based on that. But you need a lot of data to do this, okay? And then these models are then used for the targeting. Well, all of these EMIS functions I've been talking about really are built on top of sub-metering, because metering only at the plant battery limits, or as steam comes out of the boiler or out of the compressor, that is not sufficient, okay? you need sub-metering, at area, unit, and equipment level. Yeah. And because the sub-metering really determines the precision and granularity of the EMIS functions, like the accuracy of the cost and accounting, the precision with which overconsumption is pinpointed to a particular part of the plant, the accuracy of the reporting and dashboards, and precision again of how leaks are pinpointed to a particular place within the plant. Okay, so sub-metering is very important. So there's some confusion sometimes about the terminology used around all of this. So like sometimes artificial intelligence, machine learning, and neural networks might be used interchangeably, but they're not exactly the same. Okay, so artificial intelligence is kind of the broader term, and under artificial intelligence there are two branches, like engineered analytics and data science. Okay, so by engineered analytics, I mean, for example, pre-programmed, rule-based analytics. Okay, and that may include, for instance, using cause and effect, which is really the best way to do condition monitoring of equipment like pumps and compressors and turbines, etc. And it includes, first principles, such as thermodynamics, which is really the best way of doing performance monitoring of, heat exchangers and cooling towers and so on. Okay, so in fact, a majority of use cases in a plant really are using such engineered analytics. Okay, but there is also use of data science, of course. So data science again has two branches. There's like machine learning and there's deep learning. So machine learning, well, that includes regression, principal component analysis, support vector machine, artificial neural networks, etc. And that's really best used when the cause and effect or the first principles of something is not well known. Okay, for example, in the case of human behavior, humans are very complex, right? So, and there's no first principles. So that's whenever we look at analyzing human behavior, we go down the route of statistics and data science. Okay, but very complex composites, of many types of equipment and many pieces of equipment and many unit processes can also have complex interacting behavior. So in this case, again, machine learning comes into play. Lastly, the deep learning, that is more like for audio and video type of analytics. Okay, so analytics is a toolbox, right? The hammer is not the right tool for everything. Similarly, in analytics, you need to use the right tool for the job. It could be a hammer, it could be a spanner, it could be a screwdriver. Okay, you get the analogy. Anyway, so today, a lot of things in the plant is still done manually. It's only the core process control, which is really automatic, For example, to monitor steam traps, that's very manual through manual surveys, usually done yearly, okay? And since it's yearly, that means a steam trap can be blowing steam for 6 months to a year, costing you lots of money in loss of steam and, increasing your carbon footprint. So now, and also another way it can fail is trapping condensate, right? And that causes inefficiency and it can also lead to a whole host of other problems, okay? So either way, this needs to be detected fast, okay? So what plants are doing is that they're putting in sensors like the one you see on top right. So it sends acoustic noise and temperature data to the analytics that then tells you the health of the steam trap, and it tells you if it's failed blowing steam or trapping condensate. So it's descriptive analytics, not just telling you it failed or anomaly or something like that. So now you know that you need to replace the steam trap. So it's prescriptive analytics. And all of this analytics is ready-made. It's tested and proven in many other sites. You don't have to do any coding. You don't have to do the testing or pilots. It's ready to be deployed. And this is not general purpose analytics. It's purpose-built for this job, with lots of built-in subject matter expertise, that allows this analytics to do a really good job with all kinds of subjects. Yeah? Similarly, relief valves are manually inspected today, okay? Again, maybe yearly, okay? So plants put in automation for this, the sensor and the analytics. You know, sensor is not enough, analytics is not enough. You need both. Okay. So now, if the steam trap is, the relief valve is releasing, you get a precise timestamp of that, and you can correlate it to process events, and make changes to prevent releases in the future. Okay. Worst case, if the relief valve is stuck open, yeah, you get to see that too. But even if the relief valve is actually it's not releasing, but it has seeped back after a release, and it's not shutting tightly. There's a small leak, but that small leak at the seat over time, weeks, months, years, cause great losses. Okay, so you are able to detect this as well. So now you can send that relief valve for overhaul to stop product losses. Yeah. Efficiency, okay, so fouling reduces equipment efficiency, okay, and which increases power consumption because the equipment needs to work harder, okay. So of course you can clean the equipment, but cleaning, that means downtime and lost production, so that's also not good. So really what you got to do, you got to optimize the time when you clean the equipment. Now, manual monitoring to figure this out, well, it's time consuming, it's lagging, generally difficult to do, so not an effective solution. So again, plants are now automating this. So they put in the additional sensors and the software, okay? So with that, you can actually, through the software, you can tell what is the fouling happening inside, let's say, the heat exchanger, because you have the fouling factor there. So based on that, you know that, oh, do I need to clean the heat exchanger today, or can I wait until the next turnaround, or should I do it maybe sometime in between when convenient, right? And if the heat exchanger has multiple bundles, so a bank of multiple bundles, it pinpoints to which bundle you need to clean, okay? So you can actually bypass then just that bundle, clean that bundle, rather than having to clean the entire heat exchanger, okay? So a good solution. Similarly, for cooling towers, additional sensors, and that now helps you optimize based on the efficiency, tells you when to do the cleaning, so because there's if there's of the filler, or if you need to replace the filler, and also allows you to optimize the chemical anti-fouling chemical injection, okay, all to stay as sustainable as possible. And lastly, another example, air-cooled heat exchanger. I think you get it. Additional sensors and the software. And if you have an air-cooled heat exchanger, or fin fan, to call it, with multiple cells, it tells you pinpoint which cell is fouling and needs cleaning up, right? So the focus today is really on sustainability, but I cannot not mention a few words about the decarbonization megatrend, which we are embarking on, okay? Because now we're building a lot of new plants for this new hydrogen economy, okay? And if you look across the hydrogen and ammonia value chains, there are lots of plants, okay? And they are relatively small. And by that, I mean, okay, if you look at a coal-fired thermal power plant, right, those can be hundreds of megawatts, 1,000 megawatts or more, okay? Whereas if you look at these hydrogen plants, they're typically, tens of megawatts, okay? So you need to have tens or 100 times more little plants, in this economy. Now, if you need to have a pool of engineers in every plant, and operators, that would be impractical, right? So really now with this economy, we're going for remote and autonomous operation with fleet management. So you have a fleet management center that monitors multiple little plants, maybe throughout India, managed from Bangalore, but it really could be across the globe, and managed from a single location, okay? Now, if you don't have the people in the plant, you really need to know well in advance if equipment are not performing or if there is a risk of failure, so that you can send people there. Because people are not there, they are autonomous, unmanned, okay? And you don't want to send their people on a periodic basis either, just in case. You want to send people there when you really need to. And that's, again, importance of having sensors and analytics in these plants. Yeah? So, in conclusion, okay, With these solutions, plant get improved efficiency thanks to the performance monitoring. They get, they reduce their losses and leaks, thanks to release failure detection and the energy balancing, mass balancing. You see energy conservation, because cost allocation and dynamic targeting drives more responsible behavior, and they see reduced carbon emissions, really thanks to all of the above. So, in summary, I spoke about three things. First, about why plants change. Well, because they want to meet their sustainability goals. Then I spoke about how plants change. Well, through new data-driven ways of working. And lastly, I spoke about what plants are changing. They are deploying additional automation, towards hyper-automation, if you will, with additional sensors and artificial intelligence analytics. Okay? So, well, here are my contact details. So scan this QR code if you want to connect with me. And well, I'm ready for any questions because I think we are at Q&A time.
Thank you, Jonas. Thank you for the wonderful session and a wonderful perspective also in sustainability. So overall, we had a diverse topic in a, from machine to the data science to how it goes to sustainability, help the plant in improving their performance. Altogether, we traveled in this session is part manufacturing. We have a couple of questions also regarding that, but first of all, I would like to thank all of you for these wonderful perspectives all of you brought in, and it made this session very, very enriching. We have a couple of questions from the audience also. So if you allow me, then I can communicate.
Okay.
Yes. So the question to Dr. Jha is the facilities that have been shown here in your presentation are really, really impressive. How do you plan to train the say students as well as the teachers from outside so that they get more this kind of experiences and that can create more value out of it? So what is your take on it?
Yeah, so this facility, what I have shown is part of a common engineering facility center. It's not limited to IIT students only, because we have already conducted a good internship program to all students outside IIT itself. So there are more than 100 students completed their internship on this facility itself, working in the domain of smart manufacturing. We are also running our masterclass programs for every month. We are picking up one topic of related to smart manufacturing and training teachers basically and the students. So everything is available for access as it is, what we made available to IIT students. We will be running those training programs. You can join those training programs and your students can attend some of the internship programs that we will be announcing on this facility. So I think through that, the resources are available. Another important aspect, we are looking forward to extend the same in a hub and spoke model. So if your institute is willing to take this kind of an initiative, we are looking forward to just connect with you. Thank you so much.
Thank you, sir. The next question is to Dilip, sir. So, sir, as you talked about the data part and how it can, the silos, the different silos, what is already existing, how it can blur the difference between the silos. So that part you were talked about. But what about the companies which are traditional industry? How is their willingness to deploy this kind of solution? Or what is your experience on that? If you can share that?
Sure. So thanks, sir, for that question, because that's the reality, right? And you must understand that some people are ahead of the curve than the others, but a vast majority of industry, particularly in India, a lot of industry is MSME, right? Medium, small, and micro. So they're all starting from pretty much a similar place, right? I think it is not about flipping on a light switch and suddenly you are in a new state, which is all digitized and, with digital thread and all the other interesting things we've heard about today. I think it's about committing yourselves, reimagining a future where you're thinking of new possibilities, innovating around your business to drive better outcomes by utilizing these options, right? And you don't have to wait for big budgets to be approved. The first thing you need to have is intent and commitment, and then you begin to explore what are some of the areas where you can bring about improvement, and start committing yourself to it, right? By taking some first initial steps forward, right? And I know that a whole lot of people are in that area. One thing which happened, and I think that's probably the only silver lining, that the pandemic left us with, is this strong acceleration that we saw. There's research that has now proven that we've seen the equivalent of about 7 years of acceleration in digital adoption in the industry in the last 18 months. So that's how much the whole thing has advanced. But I think the journey of a 1,000 steps begins with the first step, right? Is for you to be able to start thinking about solving the challenges that you're experiencing by utilizing these new possibilities that are available to you right now. And that's where we are engaged. That's a part of the daily lives of the people who are on this panel today, right? And our organizations. So I would say that smaller organizations can make a beginning. You don't have to really have very big budgets. What you need to have is intent, curiosity, willingness to experiment, and support from the leadership to go out and try out new things, right? And once you take your first step forward, get some positive experiences, which gives you the confidence to go out and try new things.
If I may chime in, I agree with Dilip. First of all, you can't do everything in one go, right? It has to be a phased approach. Okay, and really the first step, when we have done this with many customers, and many of them in India, by the way, is that we start with a digitalization workshop, to find out what are the real problems in each plant of the enterprise, because not all plants are the same. They are different age and different industries, etc. So based on the outcome of that workshop, we then identify what are the digitalization solutions which are required. Okay, and we kind of prioritize them, so there might be a few related to energy and sustainability. It could be another few more maybe related to reliability and maintenance, maybe something to occupational safety and health, and something maybe a little bit towards production as well. Okay, and then we execute these projects in an agile approach, if you will, one by one, so that there is not too much sudden change, right? Because people can't absorb that much change. So by doing it phase by phase, it becomes a gradual transformation, which is easy for people to absorb, to incorporate into their daily work practices, without a whole bunch of disruption and conflict. Yeah?
Thank you for the diverse perspectives, and yeah, definitely. So, Jonas, with that, we'll come to you for the next question. When you showed that the preventive maintenances or the technologies what has been used for reducing, say, energy intensity, and where we are looking at a climate change kind of target, where sustainability is a buzzword right now. And every company is looking at the products, the supplier or customer, everyone is looking at how to reduce. So my question is that this is one part of it, like the predictive maintenance part. But what do you see as a data utilization of digitalization and overall value chain? Like say the virtual part, how can we more utilize that in this kind of scenario where not only the energy part we are looking at, but the product part also? How can we utilize that there?
What do you mean by the product part?
Yeah, so the product all the companies are trying to make it less the carbon footprint should be less. So one part is the product, like the energy intensity reduction in the plant, but there are other aspects like the value chain where it is created.
Sure.
How data can be enable us to reduce the footprint there? Is there?
Well, if you want to change, many people will change their process, right? You know, they might use hydrogen. Chemical plants will use hydrogen, instead of LNG for as feedstock in many cases. That, you know, like if you make like methanol or ammonia, for instance, they're going to use hydrogen as a feedstock. You know, so that is a big change. You know, which is great decarbonization, right? Well, to do that, you need more automation, you know, to make that change, you know, because, you know, yeah, you're going to need different automation to achieve that, you know. So I don't know if that directly is anything with data. I mean, data is yes, I mean, that goes into the condition monitoring of the equipment, you know, and the performance of the equipment, you know, but a lot of that is more sustainability than decarbonization, I would say. Yeah, I mean, I mean, all the little brooks add up into a river, right? I mean, yeah, you can envision the, you know, the Sankey diagram, right? You have seen all of those. So you really want to improve in all of these different places, and it all adds up.
Thank you so much. Thank you so much. I think we have 2 minutes left, but one more question, maybe we can take it up. One question is that, see, everybody is talking about more of automation, more of green, in a green, you know, kind of thing, like sustainability and low carbon footprint, and this can reduce the human factor, That's the, you know, general thinking. So in, I mean, all three of you, my question is that how this kind of thinking can change, and what is the aspect you want to highlight in this kind of scenario when this kind of questions are coming.
Let me take a. Yeah, go on, Dr. Shah. Sorry.
No, sir, you go ahead.
Let's follow the question again.
Utsab, you're on mute.
So we are going on more of automation, more of less using automation or data to have a less human heavy enterprise, maybe where human interaction is less. So in that case, there's a thinking comes that humans are less and you are using robots. So there's a conflict somewhere is coming in. So how that kind of mindset we can change? I mean, it's a question to all three of you.
Yeah, let me take a first swing at it, and then you know, Jonas, Dr. Jha, you know, please chime in with your perspectives. I'll say this. Listen, Dr. Jha spoke about the aspirations that we have as a country to be a 5 trillion, you know, GDP, 1 trillion manufacturing sector. There is just an enormous amount of new stuff that has to be done, which is multiples of what we are doing right now. We need people to be doing more, and we need more factories, you know, to produce more cars and more food and all of that kind of stuff. So our productivity has to really go up. There's no other way to look at it. And we have to become much more efficient. So I don't think, you know, it may be a poor unintended consequences. We end up eliminating a lot of jobs. But what we are trying to deal with is manage this, you know, exploding levels of complexity that we encounter in manufacturing right now, which these technologies are enabling us to do, right? And yeah, it's making us more productive. So one person is able to do much more. And humans are getting equipped to tackle challenges which a person otherwise could not have. And you've seen several examples across the 3 presentations this afternoon, right? So I'll say that, you know, the intent is not really to make human obsolete. The intent really is to augment the capabilities and get the human to do what they are best equipped to do, and equip them with the right insights and the right, you know, decision support at the right point in time so that they can take the best decisions at whichever levels. That would be my take.
Yeah, I mean, I remember one customer that we had where we did digitalization, and to this, he was speaking in a forum, and they asked him this question, and he said, "The plate is always full. There's always something to do in the plant, you know, so essentially how many tasks you eliminate, well, there's always other things that you can improve, things that you never had a chance to work on before, well, some tasks are automated. Well, now you have time to work on those other things you never had a chance to work on before, and make all of these improvements that you want to do.
Absolutely, absolutely. Yeah. Thank you. So, thank you. Thank you so much for this lively session with lots of new perspectives we